Welcome back to the AI Research Roundup. I am your host, Alex. Today we're looking at a new paper called MASKSEARCH, a universal pre-training framework to enhance agentic search capability. Now, the background here is in what are called Retrieval Augmented Language Models, or RALMs, which are models that use external tools to find information. This paper proposes a new pre-training framework to make these agents better at searching. The core idea is a task called Retrieval Augmented Mask Prediction, where the model learns to use search tools to fill in masked or hidden parts of a text, building a general ability to search and reason. And for those of you who want to explore this further, the authors have released the code for this work on GitHub. In the repository, you'll find the full implementation, including scripts to generate the RAMP question and answer data, and to construct what are called chain of thought trajectories. These trajectories are essentially the step-by-step reasoning paths the model learns to follow to find an answer. Alright, and this figure gives a great visual overview of the whole MASKSEARCH framework. You can see that core retrieval augmented mask prediction task in action. It takes a sentence, identifies key information like names and dates, and then masks them to create a question. To generate training data, it uses a multi-agent system with a planner, rewriter, and observer to build those step-by-step chain of thought trajectories. The model then learns through either supervised fine-tuning, which is like learning from correct examples, or reinforcement learning, which uses rewards to guide the model's learning process. Okay, so digging into the results of that supervised fine-tuning approach, these charts show how the model's performance scales as they go through more training steps. We're looking at different model families here, QN and Llama, across several different question-answering benchmarks. The vertical axis shows recall, which is a measure of how well the model finds all the relevant information. As you can see, for pretty much all models and datasets, the recall score climbs quickly in the early training steps and then starts to level out, showing the training is really effective at improving performance. So, building on that idea of effective training, this next figure looks at how the model is trained, comparing two different strategies. One is a mixed approach, where tasks of all difficulties are jumbled together. The other is called curriculum learning, which is where the model starts with easier tasks, like filling in just one masked word, and then gradually moves to harder ones with more masks. And what we see here is that this curriculum learning approach generally leads to better performance. The model's recall improves steadily, and it achieves the highest scores on the most difficult tasks, which suggests this progressive learning is very effective. Putting it all together, the MASKSEARCH framework is a really clever approach. By training models to identify and mask key information, essentially teaching them to formulate better search queries through that effective curriculum learning strategy. This work paves the way for more capable agentic AI. These are models that don't just answer questions, but actively seek out the knowledge needed to solve complex problems. That's all we have for this week's AI Research Roundup. Thanks for tuning in. I'm Alex.